Hi, what's up, guys? This is your very small channel, and this is the lesson where we are going to study about the periodic table. So, in the periodic table, we are going to learn a vast amount of information in the periodic table about the founder, the electronic configuration, groups, periods, and etc. Okay, so we'll go inside. So, what is a periodic table? So, many of you guys might know what's a periodic table, but the periodic table shows all the elements in the whole universe and it is one of the most important tools that a chemist uses in his day-to-day life. So, it is an important table which shows all of the elements in the whole universe. The arrangements of the elements also allow us to understand the tensile properties and make predictions. So the arrangement, the place where the elements in lets us to understand better the properties of the elements. So who invented the periodic table? So the modern periodic table was presented in 1869 by a famous Russian chemist Dmitry Mendeleev. This is Dmitry Mendeleev. Let's say a big thanks to him because of his periodic table he can do a lot of stuff in today's life. So this is a picture of a periodic table. So you can clearly see that they have divided into groups. So they have given them separate periods also, and then in this you can see that they are arranged in the again with the number here 1, then here 2, then here 3, 4, and so on. And then we are learning more widely about the periodic table. So now, what do we call these vertical columns? These vertical columns here. So the elements are arranged in the order of atomic number. The number of protons is the nuclei of the atom. So the vertical columns in the periodic table are called the groups. The first 7 groups are numbered from 1 to 7, and the final group is numbered 0. So in all periodic table they don't put numbers here. So here it will be 1, then 2, then 3, 4, 5. Up to here it is 6. So here they don't put 8 here, but they put number 0 there. Some of the groups have special names. Example, this group 1 have the name of alkali metals. This has alkali earth metals. So this is the halogens. So these are the numbered gases. So they have divided the elements into different groups. Horizontal rows, periods. So horizontal rows are called periods. The horizontal rows in the periodic table are called periods. It is most important to remember that hydrogen and helium make up the group 1. So it is basically very important to show that this H is hydrogen and the H is helium. So these two elements make up the group 1. They both are not solid. So lanthanoids and actinoids are usually rubbed out of the proper places and written separately at the bottom of the periodic table. So you might think why they have dropped out of this periodic table of here and wrote separately over here. There is a good reason for that. So that reason is if you put them it where should be, everything has to be drawn slightly smaller, right? So to fit on the page, that makes it more difficult us to see and read, right? So because of that they have dropped out from their proper places over here. See, Alantra and Etna. So now we are going to learn about the atomic number and mass number. Okay, so most periodic table have 2 numbers against each symbol. The atomic number will always be the molar number. So the atomic number means the number of protons in a shell in a atom. So the other number will be the mass number, or the most common isotope of the segment or the relative atomic mass. So here atomic number means the number of protons only. So it will be a less number, right? So mass number means the number of the mass number means so the protons and neutrons are in the nucleus of the atom, so it will be more, right? So we'll look at an example of it, and so in this we'll take an example for carbon. Okay, so in this carbon you can see that there is a 6 over here. So this 6 is the atomic number, the number of protons only. So this 12.011 maybe is the number of atoms in its nucleus. It means it contains neutrons and protons too. Okay, so when in this I might say about atoms. So you might think what an atom is. So we usually draw. So this is a 2D shape of atom. So this is what I said. Okay. So protons are in green color, and so protons are in green color, right? So 1, 2, 3, 4, 5, 6 protons are there, and then only the proton make up the atomic number. So when seeing the mass number, so we have to add the neutrons too with us. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 are there in this. So you might think, well, this red color parts I'll come to that later. So this is a 2D structure of atom. So this is the 3D structure of atom. I'll come to it later. So this is the nucleus. So this is what I said about nucleus. So nucleus contains the number of protons and the neutrons. So in this they have shown the color protons and the blue color neutrons, and this is a 3D structure of an atom. So there are 3 theories we have to follow in an atom to find electronic configuration. So you may think what an electronic configuration is. So electronic configuration is like drawing only the electrons in there. So when we do like this, so in Democritus models, he has said that atom is tiny, hard and uncuttable. So the shape of the atom explains behaviors of human. Atoms of water are round balls, that means the one have sharp teeth. So he have things like that. So then John Dalton has found that the atom is like this shape, and it will be and he said that Democritus' idea is completely wrong, and then he said it was sole, indivisible sphere could not destroy or reconstruct. So here this is J.J. Thomson. So he said that John Dalton's idea was wrong, and he said that atom is a sphere of positive charge containing a few negative charged particles called neutrons distributed in this sphere-like raisins and in a plum pudding. So people call his model as the plum pudding model, but he's nearly there. But he said that there are plus charge and positive charges and negative charges, right? So these are divisible units. So this is rather false. So he found this in 1909, and he said that J.J. Thomson's idea was wrong. And then he said that divisible units composed of positive charges concentrated in the nucleus with negative charges orbiting the nucleus. So he is more brave than that, J.J. Thomson, and he came to Neil. So this electrons. So this is Niels Bohr. So and he found this in 1913. So now in this video and in our day-to-day life, we are using the Niels Bohr's idea. So electrons in atom are restricted to certain circular orbiting about the nucleus. So similar in the planet's orbit around the sun. And then this is Schrodinger's. So this is the model from 1926 to present. Probability to find electrons within a space surrounding the nucleus. The cloud is denser where the probability of finding the electrons is high. The cloud is less dense where the probability of finding the electron is low. So in this you might wonder that why aren't we using this model, because this is more advanced than this. So there is a good idea for a good reason for that. When we are drawing electronic configuration, we can use Niels Bohr's model and draw the electronic configuration very simply and easily, right? I'll come to that later. So this is the arrangement of electrons in an atom. So this is to show that how the electrons in an atom are arranged. So the electrons move around the nucleus in a series of levels called the energy shells. We can often call that as levels. So each energy shells can only hold a certain number of electrons. So there is a unique certain number of electrons that every shell can hold. So low energy shells are always will be before the higher ones. The lowest energy shell is the closest ones to the nucleus. So in this one, you can see that there are 2 electrons in the first shell. That is the maximum amount it can hold, and there are 8 in the second shell. And there's a thing over here. The elements up to the atomic number 20 can only hold up to 8 in the third shell. So this is not an element under 20. So this is holding 18 electrons. So this is not a 20 element, but the elements rather than 20 can hold more than 8 elements. So this is how to draw electronic configuration. So to draw electronic configuration, the arrangements of electrons in an atom are called as electronic configurations. It means we can simply understand them. So this is the arrangements of electrons in an atom is called its electronic configuration. Means how these atoms are arranged. So in this we'll use chlorine as an example for this. So now look at the atomic number in the periodic table. So when we look at the periodic table, we find the chlorine's atomic number is 17, and so this tells you the number of protons. The number of electrons is equal to the number of protons. For chlorine, the electrons will be arranged as follows. So for chlorine, this will be arranged as 2 in the first shell, 8 in the second shell, and 7 in the third shell. So this is written as 2, 8, 7. When you have finished always, so this will be written as a 2, 8, 7. So when they say us to write in the electronic configuration, we have to write like 2, 8, 7 because it contains 2 in its first shell, then 8 in its second shell, then 7 in its third shell. So now we'll go to another periodic table and see this whether is correct here. So this is the chlorine atom in the seventh one. So this is chlorine. So just when you click on this chlorine, so I think basically you can see there are small balls moving around the letter Cl and chlorine. So these small balls are called the electrons that orbit the nucleus. So we'll count up them. Just pause the video and count up them whether they got 17. If there is 17 electrons, it is correct. So here 1, then 2, then 3, 4, 5, 6, 7, 8, 9, 10, and then 11, 12, 13, 14, 15, 16, 17. Yeah, there we can find 17 electrons, and this is the electronic configuration 2,8,7. So we have to come to the end of the video, guys. But this is just the part 1 of the periodic table lesson. But the rest of the video will be continued as a part 2 and will be released in the coming days. So this periodic table lesson will be continued. So like, share and subscribe my channel, guys. Have a nice day, and be waiting for the part 2 of this video. Thank you. So this is EDEXCEL channel. Have a good day. Cheers. Bye bye. And so guys, so this is not a picture periodic table. So this is a app where you can so this is that app where you can keep any live wallpaper as your desktop background. So this app's name is live wallpaper. You can go to the Microsoft Store and download and experience this app. So thank you, guys. Just go and check out this app in the Microsoft Store. It's a cool, superb app.